Alright guys, so we're working on Elli's patio problem here, and we're going to draw a picture, and we could change the scale. I actually debated changing the scale, but because we have 6.25 by 6.25, it's such a weird dimensioning, unless I like multiplied by 4 and got it to 25 by 25 boxes. I'm still going to come out with partial boxes. So I decided to just go ahead and use the 6.25. So if you count my boxes here, it's 6 and a quarter, and my boxes down this way, 6 and a quarter. So then they tell us that they're going to enlarge this patio by 1.5 meters. Now if we stick to one box being 1 meter, and we could make a little key for ourselves here if we want an indication of that being 1 meter, we are going to extend by 1.5. And then down here, we're going to extend by 1.5. But the problem is, this is 3/4. So a half would take me to just a quarter short. So 1.5 is still going to leave me a quarter short down here. So we're going to try to draw that 1/4 of the way short. And I'll erase any extra lines that I don't need. One of my favorite math professors in college, Dr. Smith, would always say, if you don't know what else to do, draw a picture. If you got no other options, draw a picture and see what starts to happen. Now again, over here, that awkward spacing of 1.5, this is 3/4, so a half would leave us there, and we're going to actually end up 3/4 out right there to do our 1.5. So we're a little short away from the box, totally fine. We're going to erase the extra. Now guys, I decided to solve this problem in real time and not do any setup beforehand to show you some of these problems take time to solve. And when you rush and don't draw things out or don't take your time, you're going to get the answer wrong, and then it's going to take you more time. So the patio doesn't really matter. It's the expansion that we need to put flooring on, right? So they're going to do tile floors that are 1/4 by 1/4 meter. Now this is where this gets tricky. That does not mean that a tile takes up 1/4 of a box here, right? Because we're using boxes as our dimensions. What that actually is going to mean is that it's 1/4 by 1/4. So if I come out by 1/4 and make a mark, and down by 1/4 and make a mark, that would be my tile. Another 1/4 gets me to half, another 1/4 gets me to 3/4. So I'm going to need 4 tiles long for every 1 meter, right? So I would need 4 tiles out here, and then this other half off to the side. So I have 1.5 right here, right? Well, 4 tiles will make 1 meter. So I could do a little drawing here. It gets a little tight, and that's why I thought about changing my scale. And then 2 more tiles. So that's actually going to be 6 tiles across. And this is what this problem is trying to make you think about, is area in terms of tiles. So we're going to need 6 tiles across. So I'm going to try to change my light a little bit to see if that'll help with the glare. I don't know if there's anything I can do to help with the glare. Yeah, I guess putting it in the dark works a little better. So then we have to figure out, well, how many tiles long will this section take? And I'm actually just going to drop a line right here and split these sections. And drop a line right here. Because I know this left section is going to be the same as this right section. So we know it's 6 tiles wide, and I'm going to go ahead and write tiles. So this is 1, 2, 3, 4, 5, 6, 7, and we said this was 3/4. So 7 3/4 meters. But we said we need 4 tiles for every meter. So the 7 is going to get multiplied by 4. 7, 14, 21, 28. Plus 3 more tiles. Sorry, my camera can't focus right now. 3 more tiles for the 3/4. I might switch over to using a pen because I think the pencil's getting really hard to see. So this 3/4 is going to give us 3 more tiles. So we get 28 tiles plus 3 tiles, which is going to be 31 tiles long down this side. So we have 6 tiles by 31 tiles. If we figure out the area in tiles of this section, it's going to be 6 times 31, 186, I believe. and that's tiles. That means that this area over here would be the same. And now we're left with this part right here. Now we know that 1.5 meters from the top of our drawing here, 1.5 meters was 6 tiles. So we know that this length right here, that edge right there, will need 6 tiles. So we know that'll be 6 by, now we just need to figure out how many tiles are going to go here. So if we count, we have 1, 2, 3, 4, 5, 6 and a quarter, which they told us before. Right, so we know a quarter of a meter is going to be 1 tile. 6 meters will be 24 tiles. So it should be 24 plus 1. We get 25 tiles will be how long this section on the bottom is. So if we do 25 times 6, I believe that gives us 150. So now this problem is fairly complex because even if we add up the amount of tiles, that's not the answer that we want. But we're going to go ahead and add up the tiles to figure out the total amount of tiles. So we've got 186 times 2, and then an extra 150, and that is 522. So we get that in total we want 522 tiles. Move my camera out a little bit. And then we're going to divide that by how many tiles come in a pack, and they tell us it is 25 in a pack. Of course, we're doing this in our calculator, and the answer we get is 20.88. Now that, of course, is not an amount of packages that we could order. So that 20.88 needs rounded up because, of course, we're always going to order extra as opposed to not enough. And that is how we get to our answer of needing to order 21 packs of tiles.